In episode 49 of Mobycast, we continue our conversation on building RESTful APIs. In particular, we discuss authentication and error handling. Welcome to Mobycast, a weekly conversation about containerization, Docker, and modern software deployment. Let's jump right in.
Hello, welcome Chris, and welcome back Rich. It's another episode of Mobycast.
Hey.
Hey guys.
Good to hear your voices. So this week we'll jump right in because we're doing a part 2 of the series on REST and REST-based microservices and how to build clean and beautiful microservices with REST APIs. Last week we just talked about a lot of basics. So this is, it's a couple of episodes that are really learning focused to help make sure that we build stuff as software developers that's useful for other people and easy to maintain and easy to understand and easy to hand off to other developers. So last week we just talked about what it is, a lot of basics, the different methods and how it works and how the naming scheme works. We talked a little bit about how, the relationship between REST and the HTTP protocol and how REST APIs are essentially broadening the HTTP protocol to things beyond just web pages. And so kind of just got our heads around what this thing is and gave examples of what to do and what not to do. And my favorite thing from last week was that we don't do something like /orders/new order as our REST endpoint. We just do /orders and we do a post to it. And that's just, that's well understood, but as well understood as it is, we, at Kelsus, we definitely see that not always being followed. And, I would argue that there are maybe times to break out of REST when it is just feeling like you're turning yourself into a pretzel to keep the exact, RESTful ideas in mind, and you just need something sort of one-off or special. But we can talk about that a little later. This week, we're going to get into a few things. We're going to talk about, I think this is a little more hardcore, so don't think of this as drier, but more hardcore. We're going to talk about authentication and error handling and something that I can't pronounce because I'm not even really familiar with it. And then, so Chris will say that when we get to it. And then maybe some helpful tools when developing your API. So let's jump in and let somebody besides me talk. Let's talk about authentication, Chris.
Yeah, so obviously authentication is pretty important with an API. You may have some APIs that are public and open to the world, and you don't really need any identity associated with that. But I think for the most part, those are pretty few and far between. So almost always, you have a case where when someone's calling your API, you need to be able to identify who they are. So to do the authentication, and then there's also the corollary, the authorization, right? So once I know who they are, do they actually have permissions to do what it is that they're asking to do? So very fundamental part of building an API. And when you're designing a RESTful API, it kind of poses this challenge. Is like, well, how do you do this? Especially given that it's, for the most part, it's a stateless communication mechanism, right? So you have clients that are making calls or sending their API calls to you over, HTTP, HTTPS, the server's receiving it, and then returns back a response. So it's this request response pattern, and each one of those things is essentially atomic. So how do you manage things like sessions or like just set up this, identity and being able to know who they are and again, doing that authentication and authorization. So pretty fundamental.
You just said something, though, that I just need to dig into a little bit because I hear this thrown around a lot, and I just want to make sure that we know what that means. You just said stateless. It's like, stateless. And a lot of application servers really do focus on being stateless. So your microservices are not keeping track of what your user is doing or the overall state of the application. But it's a bit nuanced. And I just want to point out that the overall application is absolutely stateful. You, as the user, you're looking at a client that's different as you do different things. So that state of the client is changing. So that's stateful. And then the thing in the server, the back end, let's just call this whole thing the back end, it's totally stateful too. As you write that new blog post or as you update your status in that social media app, you're changing the state of the world that's known about you in the back end. The only thing that's stateless is just the thing that's running the microservice and listening for a request and returning the response. That's the part that's stateless. Is that fair to say, Chris?
Yeah, I mean, typically when we talk about like stateful versus stateless, we're talking about the communication channel between two entities and whether or not it's stateful or stateless. So as a system, absolutely, there's always state, right? It's stored somewhere, but it becomes just a point of distinction of like, in this particular part of the system between these two entities, do they have a stateful relationship or is it a stateless relationship? And so this passing of request and getting responses back, that particular relationship, if you will, is stateless.
Right. It has no idea what the last thing you asked for was, and it's not going to predict what the next thing you're going to ask for is. It just doesn't keep track.
Right.
Cool. Okay. Continuing on in our authentication world.
Yeah. So given that, so I mean, the first thing, okay, so authentication, we have to figure out identity of the caller and how do we do that? There's a bunch of techniques out there. So one of the most straightforward, easiest ways to implement is just use basic HTTP authentication. So something like this is, again, super easy to implement. Your caller has an identity based on username and password. Whenever they send a request to your service, that username password gets base64 encoded and it gets put into the HTTP request header. So with an HTTP call, there's various pieces of that. One is there's headers on it, so it's kind of almost like the metadata about the packet of data that you're sending, and then the actual packet itself. So in that metadata in the headers is where you would store this authentication information, username, password that's base64 encoded. That's received over on the server side, and then it can then base64 unencoded to figure out, okay, this is the username and password, and then authenticate it against a particular identity store that you may have. So really, really simple to implement, right? Like the client all has it knows its username and password. It sends it over in a header. Server receives it, looks it up in the database and replies, and can either allow the request to continue or return back an error saying you're not allowed. So, but it is simple. It's also obviously it's not secure at all. Base64 is not encryption at all. It's just a way of turning. It's actually a way of describing binary data in a text format. So super easy to see what that information is. So if you do use basic authentication with your APIs, then you absolutely have to send that over TLS. You have to send it over an encrypted connection. Basic authentication over non-encrypted traffic it's a no-no. It's a big deal killer, yeah. Right? It's like, put down your pencil, put down your keyboards. You're not allowed to type anymore. Right. You're done, right? Game over. So that's basic authentication. It's really very few applications would use this anymore. It's just so simple and rudimentary and kind of legacy. And there's really no reason for doing it other than just pure simplicity. That leads into other methods that are based around essentially exchanging tokens, short-lived tokens that are negotiated based upon the true credentials of the user. So you think of this as, I have a username and password. I'm going to go authenticate with some service or entity, and it's going to validate that. And in return, it's going to give me back a short-lived token that's unique to me, that identifies me as being that particular person. And now I can send that token as part of my authentication request. And then the backend can then say, okay, given this token, is this who are they from that, and then decide whether or not to allow access to that request.
And the two advantages I think that you get out of the token-based authentication are, one, just fewer requests containing username and password information. So just reducing the overall surface area of requests that have that username and password information in them. And then the other one is the ability to deny a token or deauthorize a token without making somebody change their username and password.
Yes, indeed. Yeah. And so there's various schemes that you basically use this type of token principle. So you have things like OAuth, which is a spec for dealing with authentication. And so I believe it's the O stands for open. And so that OAuth basically defines that dance of, given my credentials, some other service is the identity provider or identity store that exchanges those credentials for one of these short-lived tokens, and then based upon that, now it can make requests on that. So that's OAuth. OAuth has various different flavors. There's OAuth, the 1.x generation of OAuth, and OAuth 2. Obviously, OAuth 2 is newer, although there's actually not as many implementations of that. It's definitely more complicated. A lot of common bigger applications that do OAuth, that use OAuth for authentication, are using either the 1.x version or some flavor of it that it's maybe even be specific to their implementation. So
that's what I was going to say, Chris. I thought the O was for the O and not consistent across implementations.
Yeah. And it's I mean, at the end of the day, it is kind of, it's open for interpretation, if you will, right? And it's up to like how folks want to do it. So Facebook authentication, it has its way of doing it versus Google versus, any other, major APIs, whatever APIs. I mean, there's an entire API economy, right? With many different APIs out there that you can call, and they all implement authentication, and they're all slightly different. So you have to just look at the details and what it is that they are expecting. So that's OAuth. One of the challenges with OAuth is, do you have to implement your own OAuth server? And that's work there. There are kind of off-the-shelf systems that you can use for that, or hosted versions, but it does add some complexity. To hide some of that complexity, there are other services that have become very, very popular for doing identity management. And so these are services like Auth0, OneLogin, Okta. There's many of these.
We talked about Cognito a couple of weeks ago.
Yeah, sure. Cognito, absolutely. So these are services really to take away some of that complexity. So it makes it very easy to get going with it. So they end up either they host the identity store, or they can federate to your identity store that may be in another service or another database, but they're responsible for doing that handshake of, given my credentials, give me back a short-lived token that uniquely identifies me and guarantees that that's me, and now I can make my calls that way. So those are typically represented as JWTs, stands for JSON Web Token. So it's just a standard format for these tokens of how to package them up. They end up literally being a JSON document with some well-defined schema to identify who the person is, and then they are encrypted with a hash to make sure that they're secure.
Right. It just helps bring a little more consistency to the whole OAuth dance, it feels like.
Mm-hmm. It takes a lot of it just takes the complexity out of it and the interpretation, if you will. So it's much easier just to use one of these common identity store services for authentication and identification of users. And that's why they're so popular, right? So kind of, it's one of those things where it's like your API is not like your API is not going to win because of how you implemented OAuth, right? It's just, it's like what AWS loves to call undifferentiated heavy lifting. So going with someone else that does that for you makes a lot of sense here.
Great. So I think we could talk so much more about authentication, but let's move on into error handling.
Yeah.
Just talk about one of the things that's even less consistent than authentication across most APIs I look at.
Yeah, this is another big area that it's just really easy to, if you don't go in with some kind of overriding principles, it can get really messy very quickly and make life very frustrating for your application developers that are using your API. So kind of understanding like what's the contract like between the clients and the back end. So what do those responses look like? How do I indicate a successful response versus a unsuccessful response? And the reasons why things went wrong. So, and this is where, again, we're RESTful APIs are built on top of HTTP. The protocol already has, well-known status codes to indicate whether things succeeded or failed. And then it has different categories for success and for failure codes, right? So, and most people are definitely familiar with this, right? So you have like 200 is one of the most popular error codes, right? And that just means, okay, it was successful. Or you have like a 201 is another successful response, but that means that something was actually created. So gives a little bit of extra information there, different, just to let you know that, yeah, something actually was done. So in general, the 200 through 299, if you will, anything in the 200s, those represent success conditions. The 300 level error codes, those are reserved primarily. Those are mostly for like redirect commands. So it's not so much that something succeeded or failed. It's just that, hey, I'm going to point you in a different direction because this is not where you should be looking for this thing. It's actually should be over here. And then you have the 400 level codes. These are for errors that happen. And the 400 level errors usually indicate, like these indicate you, caller, did something wrong, probably. So this is not something that's wrong on the back end. It's actually something wrong with you. You sent a request that was like malformed, or it was unexpected. It was invalid.
Looking for something that wasn't there.
Right, exactly. And then you have the 500 level error codes. And the 500 level error codes are, hey, something went wrong when I tried to fulfill your request. So there was something wrong on my side that really, like, so it wasn't your fault, caller, it was my fault. And so those are the general categories, and they do become important, right? Because like if you as a caller are getting back a 400 level error code, then you know that, hey, means that me, the caller, screwed up. I need to change something probably with my request, and then I can resubmit it to hopefully get a successful response. Versus if I'm getting a 500 level code, I know that, hey, it wasn't me that screwed up, it was the back end. So I can probably resubmit that request, and it may then succeed at a later time. So it's kind of important, definitely, to keep that kind of like that contract in place with your API. Be very consistent with this of, when do you return 200 versus 400 versus 500, and then also be very aware of the various codes inside of each one of those ranges that make sense. So if you're doing a get, so one of those safe idempotent operations, and it's returning back a resource representation, like that gets a 200. So it's a 200 okay. If you're doing a post to create a new item in your resource collection, that should be a 201, right? So 201 says, yes, I created it successfully and I added content and it was successful. If I'm doing a delete and the response back from my API implementation says I'm not going to return back any there's nothing to return back other than a status code because you've deleted it. So I'm going to return my status code be a 204, which basically 204 is success but empty body. There's no content associated with it. So just understanding some of the basic common codes is important to do when you're implementing your API.
Right, Chris. One of the most common things that I've seen in sort of misusing status codes is using, like on the server side, just returning a 200 even though you didn't do what the request asked for, and returning some sort of error message through a 200 status code. I see that fairly commonly, and it would be nicer if that was in the 400 range or 500 range. If some error really did happen, just really let the client know. But sometimes I remember a specific thing with you. You and I weren't working together at Kelsis, but I was working at Kelsis and you were working at a different company, and we had to negotiate a sort of a workaround, a hack, because a library that I was using just totally it took such a left turn on any kind of error code that I needed this error that you were returning to be in the 200 range so that I didn't end up in this dark dungeon of error handling that the library provided. I needed I needed to be in the happy place of the 200s, and you were like, no, I can't do that. And we eventually like had to do it. It's how it had to work. So, if you're writing libraries, make sure that the clients are also able to realize that not all error codes are necessarily bad. Sometimes they are error codes that should be easily manageable inside the client.
Yeah, and this, I think this gets into maybe like the 400 level codes as well. So there's a bunch of things that could cause a client request to not be fulfilled on the back end. So a very typical one, like you mentioned, was the content's not there. So like I request a particular entity by its resource ID, and it just doesn't exist, right? Because maybe some other client actually deleted it, or someone else deleted it. So I'm going to get back a 404 not found, right? Where everyone's familiar with this from just web browsers, right? You type in an address in your browser bar, and for an address that doesn't exist on a particular site, you're going to get a 404 error. So the same thing in your API, it should be doing something like that. In general, you have the 400 error code for that's just 400 is bad request, right? So it's something was formatted incorrectly about your request, and you return back a 400. You have another one that's pretty common would be 409, which represents conflict. And so this is a way for the server to let the client know that, hey, you tried to do something that's inconsistent with what the state is on the back end. And so kind of feels like you may be out of sync, caller. So you can use that information to now correct yourself. And
I
this
think
may
you
have been
demonstrated that bear trap memory of yours. I swear that was what it was.
I'm sure it was, because I believe what it was like, so the application was doing something simple, like you have a feed of items, and those items you want to be able to mark them as either, some of them as favorites versus not favorites. So you can have multiple apps open, right, doing this. And so in one of the apps, I can mark one as a favorite, but on the other app, it still thinks that it's not a favorite, right? And so I can tap favorite on that. And so it sends, go mark this as favorite to the server. And so the server looks at it and says, like, well, you're trying to mark the status as favorite, but it already exists as favorite. So you just sent me something that doesn't make sense. So I'm going to so I think that you probably, the state on you is not up to date. So I'm going to send back an error code letting you know that I didn't mark this as favorite because it already is. And so that represents a conflict. So I'm going to return back a 409 error code. And so that is a hint to you as a client to now go and refresh your state, right? So you can get at what really is, like, you're just out of state. So it's really useful for like when clients cache information for performance reasons. Obviously, this is a way of letting you know that your cache needs to be invalidated. And I think this was the situation that we ran into.
I think you're right. And let's just talk about one other 400 type issue, because I think it comes up a lot, and I don't know the right answer for this, but basically, if you make a request to an API and you've got something little wrong with it, like maybe it's supposed to be, every first letter is supposed to be capitalized, or there's a part of a JSON string that needs to be a string and not a JSON object. It's so nice when the API tells you what you did wrong. It's the difference between a super productive interface and one that requires lots of bloody fingers on the keyboard for days and days while you try to figure out what's wrong and why what you're sending to the API isn't working. My question is, there could be just like, we didn't have time to really document out the error responses and make them easy to understand. Like that can happen, and I get that. But there's also like I've heard some arguments about not doing this on public APIs because or on private APIs that shouldn't be available to the public, because it could present a security risk, because it could let somebody sort of reverse engineer the API by sending too much information about what you're giving it that it's not expecting. Have you heard this too, Chris?
Yeah, I mean, this is like kind of like a wide open area, and it's so specific to your API and the situation and whatnot. But yeah, I mean, you do want to take into account things like security and just how much information you are giving up, and you want to give up you want to return back information that's going to be helpful to the caller, but without divulging perhaps more information that they should have, right? So like one of the really common scenarios of this is like for APIs that have like logins, right? So it's like I'm logging in, username and password, and then I get a response back of whether or not, that was successful. And if you return back information, it's like, well, hey, the email address, the username you gave was correct, but the password was wrong. And return back in the error code, sorry, you're getting a 401, you're not authorized. So I'll give you a 401 error code. And then in the details of the error, I'll tell you, oh, your password's incorrect. So by doing that, you've now given me some information that, oh, it's a valid username. That's a valid email address. And that's information I didn't have before. And so now I can know that that's a valid account. I can now focus on like, well, maybe I can use that information to now just figure out what the password is for that. Versus if you return back something like just more generic, like either your username or your password was incorrect. You're not divulging that additional information. So I think that's one of those examples. Other ones get more maybe in the 500 level error codes where, something has gone wrong on the back end, like maybe a database is down or something like that. So like you try to connect to your Postgres database server and it failed, right? Or even worse, like maybe it's been misconfigured and the password or for the connection string is wrong or something like that. So, that may throw an error on the back end, and the error message that your error has says, maybe it does have the string like saying like, hey, the connection failed because of credentials and for debugging reasons or for whatever, right? It includes the connection string that you used. If you then just return that verbatim in your error response to the user, like that's a huge no-no, right? Like you've just divulged your database connection string to any caller that did that, right? So that's definitely a case where you need to sanitize your errors. So error sanitization is super important for the 500 level codes. Almost always, you'll never want to give back the reasons why it went bad on the back end to the caller. You just need to let them know it did go bad, because again, there's nothing that they can do, right? Like they didn't cause the database connection problem, and so that's not like they don't need that information. They can't do anything with that information other than bad stuff. So don't return that. And so you want to keep that in mind for the 400 level stuff as well. There are some you have to consider on a case by case basis where sometimes it may be like, got to be careful. Like you don't need to return all this information, but definitely like if they sent you a bad request and it was because this particular query parameter was out of range, right? That error code should, you should give them the information that lets them know, like, yeah, that was out of range. That was the reason that request was bad.
A good way to remember not to air your dirty laundry in the 500 level errors that you return to your clients is just that's a great way to take the express elevator to the #1 entry on Hacker News. People love to find somebody that aired their dirty laundry in a 500 API response and then post about it, and then everybody loves to pile on and talk about how stupid that person was for doing that.
Yeah, and such a bad way to rise to the top of the ranks and in Hacker News, right? So, like we would all like to be popular there, but that's like the wrong way. We don't do it that way, right? So,
right,
yeah. So yeah, I mean, I think that kind of covers in general error handling and 400 versus 500 level errors, and just kind of I think maybe one slight nuance that's kind of important is, in this world now of microservices where, back-end implementations are making upstream calls to other services. So it's kind of interesting, right? They end up, the back-end service becomes a client of some other service. And so now when it's making a call to that dependent microservice and it gets back a 400 error, chances are that 400 error now represents a 500 error to the original caller, right? So you can't just always just say, oh, whenever it's a 400 level error, it's this, and it's not a big deal versus 500 level error. Instead, you have to ask yourself, well, who's the caller, and what does that mean? So if my API implementation is making a malformed request to a dependent service, that probably represents a bug in my code, in my back end code. And I shouldn't be returning a 400 back to my client, because then my client thinks it was their fault. Well, it wasn't their fault. It was actually the server's fault. So it's really important to do that translation, right? That should become a 500 level error to the client, the originating client.
Right. Yeah. This bit me in a very common architecture pattern on AWS these days recently, where I was getting a 500 error back from API gateway at 502. And the 502 was really because my Lambda function that API gateway was calling was not returning what that API gateway expected.
Mm-hmm. Yeah, exactly. So it just, there's definitely some very common conventions and some best practices you can do, but just you always have to kind of consider, like, okay, who's the caller, who's the provider here, and just keep that in mind, and know that you need to do that translation as you walk through the chain of calls throughout your system.
Great. So I think we have a few more minutes, just because I promised everybody that we would get to at least the one where I couldn't pronounce it because I don't know what it is. So it seems like Hate Ops or Hate OS or something. I don't know what this is. What is that?
Yeah, I'm not sure. Full disclosure, I'm not sure I've really heard anyone pronounce it other than me. So I cannot guarantee that this is the way that other people pronounce it, but I always would call this Hate OAS. So it's an acronym. It's a 7-letter acronym for hypertext as the engine of application state. So HATEOAS. And kind of the easier way to describe this is basically just hypermedia. So this is it's Hypermedia APIs. And really what it means is it's an API style where you have just a very small number of well-known endpoints for callers to start with. And then after that, the rest of the API becomes discoverable by the responses that come from that. So it's almost like, you can think of it almost like it's like the choose your own adventure books. I mean, this may not be the perfect analogy, but you start with, your one start on one page, your one entry point, you get back the response, and in the response, it basically tells you, like, what are your next choices you could do, right? So like there may be some information there that says, like, oh, if you want to go and fetch this resource, here is the way you do it. If you want to update this resources, here's the way you do it. If you want to delete.
Yeah, let's make it concrete. So give me all the orders. I know how to get all the orders. Okay, here they are. And with each one, here's a URL to get that specific one. And here's also another one if you want to make a new one. Here's one that you can call to make a new one. And then also with each one, here's, like you said, here's how you delete an order.
Right.
Yeah.
And so that's what these Hypermedia APIs are. They're designed to be the holy grail here is something that is like completely automated, right? So you don't need to understand. You're basically automating the consumption of the API through this. It's a data-driven way of interacting with the back end. So in principle, it's something that's very appealing and very powerful. In practice, it ends up becoming not nearly as not nearly as magical, right? Because the theory is, right, the promise is that the clients don't really need to know anything other than those well-known endpoints, right? And so they start off with some path, they make the call, and they get all the information they need back in that payload that tells them what to present them all the various options they could do next, and then to go from there. And by the way, this is all based upon, again, the web, right? This is the way the web works. Then think about it. You're in a browser, you type in your known entry. I mean, think of it, it's Google, right? You just go to Google and then you type in your search. You're presented back with a bunch of different links. And then you click on a link. And what does that do? That takes you to another page, and there you get another bunch of links. And then you can decide what to do there, and you click a link. That's hypermedia, right?
Yes.
And so it's really taken that same idea and extended it to, like, this is how your API works.
The difference is the decision-making machine that's able to deal with that Hypermedia API. And the example you gave is Wetware. Like, it's our brains. We know how to handle like unexpected information, what to do about it. We can do that as people, but Yeah, no code can do that yet that I'm aware of.
Well, not only that, but it's also like the list of actions in that particular example. It's like really limited. Like you can just choose a link, right? So it's just really the only thought process is like, what link do I want to click next?
Right.
And then it's just, but the action is just click versus with like a RESTful Hypermedia API where you're saying like, oh, here's how you delete and here's how you update and here's how you get and here's how you patch or whatever like that. You have to understand, like, what are the semantics of those actions, right?
Yeah,
like
how do
that's
I present that button for deleting, and what happens when I do delete it? What do I do with that response?
Yeah. So your client has to understand those semantics, and it has to be able to recognize how to affect those actions based upon these hypermedia links that are included in the responses, right? So that's where it gets really kind of cloudy and murky, and you start, some of that luster comes off of this data-driven API thing. All that said, I have built Hypermedia APIs and it worked pretty well. I'm not
cool.
sure.
I'm still sort of torn about it, because sometimes the work to do that and to use the, for the client to use that hypermedia information that comes back, sometimes that's more overall work in a project than just being like, okay, call this whenever you want to delete. Like just telling me outside of the program, like you and me, you're the developer, I'm the developer. You tell me with words to my human brain, do this, instead of telling me through the code. Because then I have to write code that knows how to do something with. So like, I guess it just really depends. Like how much of your application really is sort of like common patterns to respond to sort of unknown sets of things. Like, well, we don't know what the URL is going to be, but every time you get this kind of resource, you're going to do this with it. And in those types of situations, it's like, oh yeah, hypermedia. But in lots of other situations, it just feels like just hard code the endpoint, just do that. Or not the entire endpoint, but just the path.
Yeah. I should point, one of the biggest reasons for wanting to use a Hypermedia API is it does give the possibility of launching, new features, increasing your API, the functionality of your API without any client change, right? That's the holy grail here. So I think, in certain situations, this makes sense to try to go do this. So if you have a pretty kind of simple application, but you want to be able to extend it to it and maybe add, it could be like the CRUD on just new things, right? So it's like you go from maybe orders to then also include like shipments and sales and stuff, whatever it may be, right? Other things, maybe something like that lends itself well to something like this, where you can kind of keep it pretty discrete in like the semantics of it, but you want to continue expanding like the coverage of the types of resources that involves. Mm-hmm. And you don't have to make any updates to your client. So you can have a mobile app and you don't have to push any updates to the store to be able to consume the new API, because it's all data driven, right? That's pretty attractive.
Right.
But again, you have to balance that out with like, okay, can I really cover the semantics of this adequately in that client?
Right.
To take advantage of that condition.
Yeah, and I feel like, this is just such an important thing, making this decision whether to use hypermedia or not, because it really does impact the, learning on the team, time to build stuff. And I just want to point out that I think that if you're building something like an order system or a sales system, it's more likely that the reactions to the various different types of resources in that system or objects in that system are going to be very, very specific to that thing that you're working on. So you handle an order entirely differently than you might handle an invoice. And therefore, that kind of system might lend itself less to hypermedia than for example, like a social media system where, hey, there might be posts for, I can share a map, I can share a video, I can share a photo, I can share a thought about myself, or a little friendly widget that I draw on my phone, like all different kinds of things I can share. And they're all different objects, maybe in different tables in a database or something for whatever reason. So they have maybe different endpoints. But at the end of the day, the application might be able to use sort of a similar mechanism for displaying each. Let me just get the stuff that I'm supposed to show to the user. And in that case, it could be really, really handy to do that, because then I can just throw a new Hypermedia API in it, and I just like added the ability to add a VR video to my feed without changing the client.
Yeah, I mean, you bring up a good point. Like, it doesn't have to be all or nothing, right? You can have, you don't have your entire API doesn't have to be a Hypermedia API. You can just use it for some parts of it that make a lot of sense. So, again, all that said, like, Hypermedia APIs are interesting, but also like the real world practicalities of implementing them and consuming them, not straightforward. So, given that, I've done many APIs. I've implemented many APIs, and of all those, really one was a Hypermedia API. So, take that for what it's worth. That like it is a limited use case for it, but it's something it's good to know about and to be able to consider when you are building your API.
So we're totally out of time, but you know what? We were going to talk about tools for developing your API, and maybe we can just quickly say API is pretty cool. Lets you do stuff, lets you define the API, lets you even use it a little bit, just in a mock kind of way. And Swagger is a language for sort of defining the API that you can use inside of API or in other tools as well. Did you want to quickly add?
No, I would just, again, like, if you are building APIs, by all means, please do yourself a favor and go and use one of these tools. So there's so many of them out there. They're all really good. So API, Swagger, Kong, they all allow you to basically define your API, provides nice documentation for it. They provide mocks for you, so you can be up and running with, like, your clients can actually hit the API and get back responses without writing a single line of code, right? It's really a great way to just get going and to really focus on the actual development of the spec, the defining of the API. So absolutely, definitely go use one of these tools when you build your APIs.
Very cool and great conversation. And thanks for putting this together, Rich, if you're still there. And
sorry, I was on mute.
Rich is asleep.
APIs.
No, Rich's company Secret Stash has been developing an API for us to use for our client construction instructions. So this is, hopefully Rich was not asleep and was getting a little something out of this himself.
Awesome.
All right. Thanks so much, Chris and Rich.
Right. Thanks,
we'll
guys.
Talk to you next week.
See ya. Bye.
Bye.
Later. Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/49. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.